Okay, we're going to find the intercepts and the asymptotes for this one. Okay, whenever you do problems like this, the first thing you want to do is always factor both the top and the bottom. This is because sometimes you might get something to cancel out, and if that happens, you want to make sure you cancel it out first before you go ahead and answer these. So if it looks like something can be factored, go ahead and factor that one first. So for this, we're going to first, across the top, we're going to take out a common factor. X is the only one that we're allowed to take out of the top. The most you can pull out is the smallest power of x. So the most you can pull out is x, and that would be it. The bottom one, we can pull out a 2, and again, the lowest power of x we can pull out there would be the square. So if we take out that one, we would get a 1 plus 2x, and that would be left over. What we do notice about this one is you can cancel out one of the x's, and so we definitely want to do that first before you attempt to answer the rest of these. So I do want to cancel that one out. What will happen is x cancels out from the top, and on the bottom it'll get rid of one of the x's here, which means you have 2x times 1 plus 2x left over, and that would be the most you could do. You can't cross cancel these x's because it's connected here with a minus sign, so that would be as far as you could go as far as reducing it. Now this part that's reduced, that's the one you want to use when you answer these questions. So you see what the importance is. So for instance, if you do x-intercept, the x-intercept is where you set the top equal to 0. If we didn't cancel the x out, that means that we'd be setting both of these equal to 0, and I would get 2 answers for x-intercept, when in fact there actually is only one x-intercept because we've canceled out that extra term. So x minus 3 equals 0 means that 3 is the only one that we're going to have. So this right here, 3, that's the only x-intercept you're going to have for this one, and you want to use this reduced form. Next, we're going to do the y-intercept. Y-intercept, you put in a 0 for x. If we use this one, we have 0 minus 3, 2 times 0, 1 plus 2 times 0. Now what happens there is because the bottom one, you have a 0. 0 times anything is 0. So you get negative 3 over 0, which is undefined. So whenever you get undefined for either the x-intercept or the y-intercept, what you can put here is you're just going to put none. There is no y-intercept because when we solve for it, we got undefined. So it doesn't mean that the y-intercept is undefined. It means that we actually don't have any because we could not actually solve for anything. So if that happens either for the top or the bottom, you're just going to put the word none for that one. For the vertical asymptote, so the vertical asymptote, you're going to take the bottom one and set the bottom equal to 0. You want to use this version, the one that's already been reduced. So 2x times 1 plus 2x equals 0. And if you set each individual one equal to 0, you have 2x equals 0, 1 plus 2x equals 0. This will give you x is equal to 0. This one here, if you solve it, you're going to get x is equal to negative 1/2. So when you write your answer, you got to make sure you put the x equals there as part of it. X equals 0, x equals negative 1/2. If you just put 0, negative 1/2, that's not technically correct because it's not an equation of a line. You need the x equals there for both of those. The horizontal asymptote requires you to have a y equals. So horizontal asymptote, that's where we're going to be using these rules. Now the horizontal asymptote, it is okay to use the original one because the original one is still going to have the correct powers. You want to look at what the highest power on the top and highest power on the bottom. It's okay to use the original one for that. If we look at this, the highest power on top is 2. The highest power on the bottom is 3. So in this case for the horizontal asymptote, what we have is we have an example where the n, the highest power on top, is less than the m, which is the highest power on the bottom. If you look at those rules that I gave in the notes, that's going to be our rule number 1. Rule number 1 says that the highest power on top is less than the highest power on the bottom. Automatically, your answer is going to be y equals 0. So again, don't forget the y equals there because you need to make sure it's the equation of a line. So for this, we're not graphing this. The graphing is going to come in the next section, but this information is going to be very important when we get to the point where we are setting up our graphs.